Hi, good day, and thank you for taking the time to view our web demonstration today. My name is Marcus, and I'll be your application specialist, taking you through today's web demo, where we will be using the Cobalt in an array setup to scan the car door over here. So as you can see, we have 4 units set up to form an array. And before we proceed with the demonstration, I just have a quick PowerPoint presentation to share with you. So, the agenda for today's demonstration will begin with us giving you a company overview of Faro, and then we will proceed into a system review of the Cobalt itself. And following all that, we will also share with you some application examples and mounting options for the Cobalt. And after all that, we will proceed into the hands-on inspection using the Cobalt array system on the car door. So we expect today's demonstration to last about 30 minutes. So beginning with the history of Faro, we began in 1981 with the articulating arm technology in the medical 3D component industry. And in 1994, we transitioned to the industrial manufacturing markets. In 95, we introduced the Faro arm. And since then, we have come up with a host of different kinds of equipment, including the laser tracker, the focus laser scanner, uh, LLP laser line probe, as well as this Cobalt array imager, which you will see the demonstration for today. So to give an idea of our global footprint, we have our global headquarters located in Lake Mary, Florida in the US. Our European headquarters is located in Europe, and our Asia Pacific headquarters is located here in Singapore. So before we proceed into further details about the Cobalt, I will just share with you our product family. So the articulating arm technology that I talked about is in its latest form, the Edge Scan Arm HD, and this provides you with contact measurement using the probe, as well as non-contact measurement using the laser line probe and the blue laser technology. This will be suitable for part sizes up to 5 meters. And then we have the Laser Tracker Vantage S, which allows you to measure using contact measurements, part sizes up to about 80 meters in size. Today we'll be going through the Cobalt Array 3D imager, so I will save the details for the later slides. We also have the Laser Projector Tracer M, which is a laser projector projecting laser lines of features onto your part to tell operators where, for example, to do drilling, welding, or placement of parts for assembly, or even for carbon and ply layout. Then we have the Focus 3D X series, which is a laser scanner used mainly for scanning building facades, for beam sim or building information modeling, civil information modeling, as well as accident and crime scene scanning. And lastly, we have the Freestyle 3D scanner, which is a handheld scanner suitable for product design and reverse engineering. Today we will be going through the Clam2 Measure 10 software with the Cobalt, but we also offer a suite of software, and we also offer compatibility with third-party software and our equipment such as Geomagic and Polyworks. So, a bit more information about the Cobalt Array 3D imager. It is an automated non-contact coordinate measurement machine, and there are actually two camera resolutions available, both 5 and 9 megapixel, which correspond to 5 million and 9 million points respectively. There's also an interchangeable lens kit that comes with each set that you order. So with the 500mm lens installed, which I have today, it gives you an accuracy of 50 microns and the field of view for a single unit of 500mm length, 350mm breadth, and a depth of 300mm. Switching over to the 250mm lens, you get a 27 micron accuracy, as well as the field of view of 260mm length by 200mm breadth and 90 millimeters depth. The technology involved in the imager is actually a DLP projector projecting blue light onto your part. So with the light reflected off your part, it will be captured by the left and right cameras, which you see in the picture. And with the left and right cameras capturing the reflected light off your part, what you will obtain is a point cloud of your part, which you can then use to perform some kind of analysis such as CAD comparison. There's also a embedded computer on the Cobalt on each unit. So what this provides for you is a fast dedicated point cloud processing. And on top of that, with an onboard computer, you can give you the ability to connect multiple units. So if you have a part size that is larger than the field of view of a one unit, you can, in this case, connect multiple units up in order to obtain a scan of your part in one um, operation. The unit is also lightweight at 5 kilograms. So mounting in an array, multiple units in an array will not be an issue. And if you have a single unit operation in the field, it's also easy to mount it on a single tripod. There's no field calibration required. So what this means is that once you've done your first calibration in the office, you can bring it to the site and you'll be able to conduct your scanning multiple times without needing to do calibration at the site. So there are various deployment options for the array imager. You can mount it a single unit on a tripod for reverse engineering or non-recurring inspections. Uh, with it mounted on the tripod, you can use it with a rotary table, which is good for automated inspection of small parts. Today we will be going over the multiple imager array scanning. So as you can see, with one project and multiple units hooked up to one computer, you can conduct a scan of a bigger part in a short amount of time. And you can also mount the Cobalt on a robot arm in order to obtain fully automated inspection applications. So here are some of the industries which are really relevant for the Cobalt imager. So it's useful in the automotive, aerospace, energy, railway, shipbuilding, medical, as well as sheet metal. And as you notice, for most of these industries, a lot of it are using the Cobalt for product development, and especially quality control or part inspection, as well as perhaps reverse engineering. And multiple types of free-form surfaces can be scanned easily. So this provides you with a quick and easy way to obtain a scan of any part in a short amount of time. And another advantage of this Cobalt is that it uses blue light technology, as I mentioned in my earlier slide. So what the blue light means for you is that you can scan either light or dark, matte or glossy finishes, surface finishes, without the need for special surface preparation. So what you will need to set is an exposure setting, and I will demonstrate that to you during the demo itself. So I'll proceed into the imager array demo right now. And I've opened up the CAD drawing of the car door in the project already. And once you have done so, the process of getting started on your scan is very simple. Once you have connected your units to the computer and done an initial calibration, you just need to go to the Measure tab, select Point Cloud. As you can see, a window appears, and this is like a wizard which guides you through the scanning process. So there's minimal amount of training required. There are just a few simple steps. So the first step I will do is to select a scan profile which I have previously saved. And as you can see, the first thing you have to do is turn on the rangefinder over here. And when you turn this on, a red box appears in both the left and right camera views. So the idea is that you should have this cross that you see on the car door fall within the red box on both the left and right camera views. Once you have done so, you know that this particular unit is in the correct focus range to the car door. The next would be, as I mentioned, to set an exposure setting in order to capture your part. So as you can see, I've set an exposure of 25, and with that, my part itself is colored in a grayish tone. If I increase the exposure, you can see that the color turns red for the car door and the area around it remains blue. So what this means is that the red areas are overexposed and the blue areas are underexposed, and information will not be captured from the car door at this exposure setting. But if you have a darker finish surface, perhaps a higher exposure setting may be useful. So if you have a part that has both light and dark colored finishes or surfaces, you can actually set multiple exposures for your scan. So I can add this as well into my scan. So at the same time that it scans the light, it will scan the dark. So because my car door is a uniform color, I'm going to delete this exposure setting. So in the case of an array, you have your 4 units set up to cover different areas of your part. And you will just need to set a scan profile for each of the 4 units. In this case, since my car door is a uniform finish, I will be using the same profile for each of the 4 units. And you can see the second unit is in focus as well. So next, I'll move on to the third unit. Set the scan profile. Check the focus. Okay. Okay. So all 4 units are in focus and they have the correct scan profile set. And we are ready to begin our scan of the car door. So before I do so, I will just change the camera angle so that you can get a better view of the scan happening. So I'll be scanning, and the first unit is scanning the first section of the car door, followed by the second unit, followed by the third unit, and followed by the fourth unit. And because these 4 units are calibrated together as an array, the 4 scans that you take are automatically registered and stitched together. And I'll show you the result right now. So as you can see, we've gotten a very good result of the car door. And before I perform any alignment with the CAD drawing, I'll just do a quick cleanup of the car door point cloud that we've scanned. So we'll just remove the irrelevant points. Now we are about ready to perform the alignment of our point cloud with the CAD drawing of the car door. So I'll close this window. And if I go to the alignment tab and select align point cloud, adjust the point cloud for you to get a better idea. And then the same for the car door CAD drawing. And we just perform an automatic alignment at this point and see if the software will be able to align the point cloud with the car door. So if the alignment process is a little bit off, you can also select common points between the point cloud and the CAD drawing in order to get a better alignment. So if I select point here, the point here, and let's see if the result is better. Yep. So we have a better result right now, and if I close the alignment window and we return to the original screen, you'll be able to see the color map of our point cloud over the CAD drawing of the part. And at this point, you can do a few things. We could perhaps create a deviation marker area over a certain area, and you can increase or decrease the number of points by increasing or decreasing the grid size, and when you're satisfied, you can press enter. And we get the deviation markers for that point. Once you're satisfied, you can go and generate a report based on what we've done so far. So I'm going to include the point cloud in my report. If I scroll down the preview, we get the last seen screenshot from our software view just now. If I scroll further down, you get a summary of the point cloud that we've taken. So 4 units produce a single cohesive point cloud with a summary of the points that are under, over, or within the tolerance. And for the deviation markers that are generated, for each one, we get the deviation value in accordance to the CAD drawing. And when you are satisfied, you can export this report in CSV, PDF, text, or Excel formats. So this makes it really convenient. So that brings me to the end of our web demonstration for the Cobalt Array system. We hope that you found this session useful and that you saw how simple it is to get started on scanning a larger part with multiple Cobalt units in an array. And once you have this array system calibrated together, you can move them as is to any position or to any part anywhere in the field and perform a scan for the same field of view for the 4 units. And all of the scans will always be registered and stitched together in a complete image. Thank you once again, for taking the time to view our web demonstration today, and we hope to see you soon. Thank you very much.